So we're going over 6.2, solving systems of linear equations by substitution. By the end of today, you should be able to solve system of equations using substitution. Now, solving by substitutions, these are the steps. The first step is to rearrange an equation so its style is variable equals. What does that mean? That means that if you have an equation such as 2x plus y equals to 3, you want to rearrange it by subtracting the 2x on both sides, and you get the variable equals negative 2x plus 3. Now, in this case, I chose y, but don't get too caught up on the variable, as it could be y equals, x equals, z equals, any number. So don't worry about the variable. We're going to be using x and y for today's lesson, but it can be any variable at any point, as long as it's the variable equals. The second step will be to replace the variable in the other equation, and then the last step will be to solve. So if you're given this equation, and you're giving a second equation, right? And we rearrange this one into y equals negative 2x plus 3 as we did in the bottom. We're going to grab and substitute the y for this new y, and like this. And lastly, we would just solve. So we get negative x plus 3 equals to 5. Subtract 3. Negative x is equal to 2. So we get that x is equal to negative 2. So these are the steps. The first step, I'm going to highlight in blue. You want to rearrange it into a y equals. Step 2, which is replace, we're going to grab this and plug it into the other y. So it will get like this. And step 3 would be to solve. So we get what the other variable is equal to. So in order to solve for this system of equations, remember our answer is going to be xy. This is the same thing we've done with graphing, but instead of graphing, we're going to plug in and solve. So we solve for one variable. This one's done because we have this one already solved for. So the second step will be to substitute. Now we're going to grab this y, which is a 3 plus x, and plug it into the other y. So you're going to get x plus 3 plus x is equal to 5. So we substitute it in. The third step would be to solve for the equation. So then we get 2x plus 3 is equal to 5. I'm going to subtract by 3 on both sides. That will leave me with 2x is equal to 2. So we get that x is equal to 1. There, we solve for the equation. So here, this is the second part of how to solve for it. We have, remember, x comma y. And from the last slide, we figured that x was equal to 1. So in order to find the other variable, we have to plug that 1 into one of the equations. The key being the original equation. That's the key right there, original equation. So I can plug this 1 into either original equation. I'm going to plug it into both so you guys see it. So I'm going to plug into the first, 1 plus y is equal to 5. I'm going to subtract 1. I'm left with y is equal to 4. If I were to plug it into the other one, I get y equals to 3 plus 1. To get y is equal to 4. We plugged it back into the original. Now, you don't have to plug it into both. I'm just plugging it into both so you guys have both options. The key right here is that we get the same answer. That's why it doesn't matter to which one you plug in, as long as you plug it into the original. So our order pair for the answer is 1, 4. Now, how do you check if that's right? You're going to plug those two numbers, again, into the original equation. So I'm going to plug into the first one. 1 plus 4 equals 5. When I simplify this, I get 5 is equal to 5. So it works for the first equation. I'm going to plug it into the second. 4 equals 3 plus 1. So 4 equals to 4. So it also works for the second equation. That's how you guys check if your solution is correct or not, by plugging it back in. If the numbers end up equaling each other, you know you did it correctly. So the order pair, or for our answer, is 1, 4. So in this one, the first equation is the one that's already solved into a y equals, so a variable equals something. So I'm going to plug that y into here. So it's going to be 2x minus 3, 6x minus 11 equals negative 7. Now I'm going to go ahead and distribute to get negative 2x minus 18x plus 33 equals negative 7. Negative 18 minus 2 is negative 20x plus 33 equals negative 7. Then I'm going to go ahead and subtract 33 from both sides. So I get negative 20x is equal to negative 40. I divide by negative 20 on both sides, and that leaves me with x is equal to 2. Awesome, we found the first part of our equation. We still now have to find the y. Now, I'm going to plug that 2 into both equations, as long as it's the original. If you plug it into one and not the other, is fine. I'm going to plug it into the first one first. So y equals 6 times 2 minus 11. Y equals 12 minus 11. So we get that y is equal to 1. That is if you plug it into the first. If you plug it into the second, we get negative 2 times 2 minus 3y is equal to negative 7. To at least me with negative 4 minus 3y equals to negative 7. I'll add 4 on both sides. That leaves me with negative 3y is equal to negative 3. Then I'll divide by negative 3 on both sides. And that'll leave me with y is equal to 1. So if you notice, it's the same thing for both. So we found the order pair to be 2, 1. Now, let's check it just to make sure our work is correct. Again, for the second part, you can either plug it into one or to the other. You don't have to do both. I'm just doing both. In the case that you plugged it into one and not the other, you have to work for both. Now, I'm going to plug them in again into both equations just to check our work. But once I plug it into the first equation, get y is equal, so 1 is equal to 6 times 2 minus 11. That's going to be 1 is equal to 12 minus 11. We get 1 is equal to 1, so it worked out. And we plug it into the other. Negative 2 times 2 minus 3 times 1 equals negative 7. So we get negative 4 minus 3 is equal to negative 7. So we get negative 7 is equal to negative 7, which it worked out for both equations, so we know we did our work correctly. So now we're going to plug in the second equation into this y because it's in a variable form, y equals. So they get 2x minus 3. Now remember, this y is entirety is x minus 1. So because this y is completely x minus 1, we're going to have to plug it like this. Equals to negative 1. Then I'm going to go ahead 2x, and then I'm going to have to distribute minus 3x plus 3 equals negative 1. So negative x plus 3 equals negative 1. Subtract 3, subtract 3. Negative x is equal to negative 4. So we get x is equal to 4. Now I'm going to plug that into the original equation. Again, you can do whichever. Y equals 4 minus 1. So we get y is equal to 3. If you happen to have plugged it into a different equation, I'm going to plug it into the other one as well. 2 times 4 minus 3y equals negative 1. 8 minus 3y is equal to negative 1. Subtract by 8, subtract by 8. So I get negative 3y is equal to negative 9. Divide by negative 3 on both sides, and I end up with y is equal to 3. So we end up with the same y for both. So that's why it doesn't matter which one you plug into first. And again, as long as it's the original. Now, our answer would be 4, 3. But I'm going to plug them in just to double check. Again, you don't have to do this during your quiz or test, but it's just good to know. It's good to practice. So we have 2 times 2 minus 3 times 3 equals negative 1. So I get 4. Sorry, not 2 times 2, it's 2 times 4. 2 times 4, so I get 8 minus 9 equals negative 1. So I get negative 1 is equal to negative 1. So it works for the first equation. For the second, I do 3 equals 4 minus 1. So I get 3 is equal to 3, which works for the second equation as well. So we know we did a good job. 5x minus 4, negative 3x plus 5 equals negative 3. 5x plus 12x minus 20 equals negative 3. 17x minus 20 equals negative 3. Add the 20 on both sides, and I get 17x is equal to 17. I get x is equal to 1. Now I plug that in. Y is equal to negative 3 times 1 plus 5. Y is equal to negative 3 plus 5. So I get y is equal to 2. Again, if you plug it into the other one, it won't matter. You should get the same answer. So when I do that, I get 5 times 1 minus 4y equals negative 3. So I get 5 minus 4y equals negative 3. I subtract 5. So I get negative 4y is equal to negative 8. And when I divide, I get y is equal to 2. So it matches, so we know at least we did the work correctly and we found the right x. Now, how do we check it? We plug it back in. So we get 2 is equal to negative 3 times 1 plus 5. 2 equals negative 3 plus 5. 2 equals to 2, so we know it worked out for the first one. Then 5 times 1 minus 4 times 2 equals negative 3. So 5 minus 8 equals negative 3. 5 minus 8 is negative 3, so we get negative 3 is equal to negative 3. So it worked out for both. Now, for this one, guys, it's not in a variable equals form, so you do want to rearrange at least one of them into a variable equals. I'm going to rearrange this first one. So I'm going to get negative 4x plus y is equal to 6. I'm going to add 4x to both sides, and I'm going to be left with y is equal to 4x plus 6. Now I am able to plug that y into the other equation. So I would get negative 5x minus, remember that minus needs to be distributed to the whole y, not just the first term, so we're going to put a parentheses. 4x plus 6 is equal to 21. Then I get negative x minus 4x minus 6 is equal to 21. So I get negative 9x minus 6 is equal to 21. I'll add 6 on both sides. And I get negative 9x is equal to 27. So I get x to equal to negative 3. Now I'm going to go ahead and plug that 3 into either original equation. So not the one we changed, into the original. So I'm going to go ahead and plug it in. I'm going to plug it into the second. So negative 5 times negative 3 minus y equals 21. So 15 minus y equals 21. So I'm going to go ahead and subtract 15 from both sides. And I get negative y is equal to 6. So we get y is equal to negative 6. Now, if you were to plug it into the other one, I'm going to plug it in as well. It's 4 times negative 3 plus y is equal to 6. So I get 12 plus y is equal to 6. I'll subtract 12 on both sides, and that leaves me with y is equal to negative 6. So again, these two match perfectly. So again, we did something right. Now, I am going to check it by plugging in our ordered pair of negative 3, comma, negative 6 into both equations. So if you get 4 times negative 3 minus 6 equals 6, so I get 12 minus 6 equals 6. So then I get 6 is equal to 6, so it works out for the first. We're going to do the same thing for the second. So 5 times negative 3 minus negative 6 equals 21. So I get 15 plus 6 is equal to 21. So I get 21 is equal to 21. Since it worked for both equations, we know our ordered pair of negative 3 comma negative 6 is the right solution. So for this one, we're going to plug this negative 2 because we have y is equal to negative 2 into the other equation. So 4x minus 3 times negative 2 equals 18. So I get 4x plus 6 is equal to 18. I'll subtract 6 on both sides, and I'm left with 4x is equal to 12. Divide by 4, divide by 4, and I get x is equal to 3. So we have 3 comma negative 2. In this case, the negative 2 is already given to us right here by telling us y equals that number. So I'm going to go ahead and check my work by plugging it into the second equation and solving for it. So I get 4 times 3 is 12, plus 6 is equal to 18. So I get 18 is equal to 18. So we know we did the right work. Now, if you plugged into the first equation, you're going to get negative 2 is equal to negative 2. Because it's also the letter they gave us, which is y equals to itself. So it's good to check it when you plug both points in. So the first equation is solved for us already as our variable equals. In this case, is the y. So now I'm going to go ahead and plug it into the second equation. It's negative 3x minus 2. Please make sure you don't forget the parentheses, as the whole thing for the first equation is the y, not just the 5x. Equals negative 12. Now I'm going to go ahead and distribute, so I get negative 10x plus 14 is equal to 12. Now I'm going to combine the x's to get negative 13x plus 14 equals to 12. I will then subtract 14 on both sides, and I'm left with 13x is equal to 2. It's negative 12. I knew there was something happening. Yes. So everything else is fine. It's negative 12. I forgot to write the negative. I'm sorry. Just wrote it in. So negative 14 and negative 12 is negative 26. So then I divide by negative 13 on both sides. And I'm left with x is equal to 2. Now I'm going to go ahead and plug in the 2 for either equation. I'm going to plug it into the first one to solve for the y, as y equals 5 times 2 minus 7, y equals 10 minus 7, so we get y is equal to 3. And then for the second, I'm going to plug it in just to double check. So I get 3 times negative 3 times 2 is negative 6, minus 2y is equal to negative 12. I'll add the 6, left with negative 2y is equal to negative 6. Divided by negative 2 on both sides, and I'm left with y is equal to 3. So again, it matches, so we know we did something right, but we are not done because we have to check it. Again, in the test and the quiz, you don't have to, but if you had time, I highly do recommend it. So our order pair is 2, 3. We're going to plug that into both equations. So when I do that, I start by plugging in the y as 3 equals 5 times 2 minus 7. That's going to be 3 equals 10 minus 7. So we get 3 is equal to 3. So we know it works. So the first equation is good. Let's plug it into the second. Negative 3 times 2 minus 2 times 3 equals negative 12. So I get negative 6 minus 6 equals negative 12. So I get negative 12 is equal to negative 12. Therefore, I know it works for that second equation. So we know we did the right math, and we got the correct order paired. All right, since there are no questions, you guys have homework, and it's already on Canvas. But that's it for today's lesson.